Now we are going to consider meter bridge. Generally it is known as meter bridge because the wire we are using having a length of AC is of 100 centimeter or 1 meter. That's why it is called meter bridge. In meter bridge we are going to accept, or we are going to have two resistors R1 and R2, from which we can consider one of them resistor is unknown. So practical application of meter bridge is to evaluate the value of unknown resistance as we are doing in practicals. And also we are going to use the condition of the Wheatstone bridge. Now we are considering that we have four resistors R1, R2 and two different resistors, but we are having a wire of length AC, so we know that if we have some wire there is going to be some resistance with it, and that's why we are considering that we are going to achieve the null point at a point T. Null point is the point at which the current is going to be zero in the galvanometer. That is called a null point. So we are considering that Wheatstone bridge condition for this circuit. R1 by the length of AD and is equals to R2 by the length of CD only. We know that the first one, that is AD, has a length of L1 and CD has a length of L2. So we can say that R1 by R2 is equals to rho L1 and upon rho L2. Rho is called resistivity of the wire and that is going to be constant throughout the wire. That's why we can cancel it, and that's why our equation tends to R1 by R2, that is equals to L1 by L2. But we know that L is equals to L1 plus L2, so we can say that L2 is equals to 100 minus L1, and L2 is going to be considered as 100 minus L1. So R1 by R2 is equals to L1 upon 100 minus L1. If we are considering that our R1 is unknown resistance, we can make it to the subject that R1 is equals to R2 L1 upon 100 minus L.